We'll conclude the day with a big example. Function composition. Okay. So what I'm going to do is I'm going to define square. And I'm going to define triple, which just returns 3 times x. So here are some simple functions. But now I'm going to define a higher order function called compose1, which takes in 2 different functions, each of which takes 1 argument. And it defines a new function h, also over 1 argument, which returns the result of calling f on the result of calling g on x. So this is composing the functions f and g into one new function, h, which will return. Okay, so how does this work? We can square 5. We can triple 5. Now we're going to define a new hybrid function called squibble, which involves composing square and triple together. Okay, so squibble is a function where when I call it on 5, 5 first gets tripled and then that gets squared. 15 times 15 is 225. So compose1 is very general. It takes any 2 functions and composes them together. For instance, we can also make tripair, which we create by composing triple with square. So if we tripair 5, we get 75. Because we square 5, that's 25, and then we triple that, we get 75. We can even squatter. What's squatter? Well, that's a function that is created by composing square with make adder of 2. So this gives us a function that adds 2 to things. This squares. And if I want to squatter, let's say 3, then 3 plus 2 is 5, and that squared is 25. By the way, you can write one call expression that does all of this together. Let's look at the environment diagram for that one. Okay, we have square, we have make adder, we have compose1. We call compose1, which defines the adder function and returns it. Now we've passed that into compose. So compose has f bound to square and g bound to adder, at which point it will define h and return it. So I made everything smaller so that it's going to fit. So what happens? Well, h is going to call f of g of x. F is square. First we need to compute g of x, which involves calling the adder function, where k is bound to 3 and n is 2, so that gives a return value of 5, which gets passed into square, which returns 25. The answer to h is 25, and therefore that's what you get for this whole expression. Whew. Let's take a look at that image. This is the same thing you just saw, but I'll annotate it a little bit. So when we evaluated this whole call expression, first we evaluated the operator. Compose1's easy to evaluate, square is easy to evaluate, but this is a call expression that involves some work. So we called make adder on 2, and the result was an adder function. Then we called compose1 on square and make adder, and the result was this h function. And the return value of make adder, the adder function, was passed as an argument to compose. You can see that here. Compose is here. It has one of its arguments, is g, the adder function. Okay, so now we have h. Now we can call h. What happens when we call h? Well, first we evaluate f of g of x, which involves evaluating g of x in this environment. So what's f? Here. What's g? It's there. What's x? It's there. And in order to get g of x, well, I have to call adder. And so k plus n, the body of adder, gets evaluated in this environment, which has 3 frames as well. What's k? It's there. What's n? It's there. So there are two different environments, each of which has a length of 3, and together they help us compute the number 25.